Hello, so let us look at number 5 from year 2010. Okay, let's get started together here. So I'm going to give you a little bit of time for you to look at the question, and then we'll talk about it together. So here we have function g is differentiable function from -7 through 5. And they gave you one initial condition here, g of 0 is equal to 5, where the graph that's given is g prime. Notice that. Now, then find g of 3. So let's try to look at part A first. G of 3, in order for us to get to this one from g prime, we have to integrate. So first, which we can do is from 0 through 3, because we know the value of 0, and we want to get to the value of 3. Then we end up getting g prime of, I guess, x. Let me use x here. Dx. By the fundamental theorem of calculus, this will be equal to g of 3 minus g of 0. What is g of 3? That's what we want to calculate. What is g of 5? We know that answer already, 5. This one is simply the area under the curve from 0 through 3. Since here this portion is a quarter circle whose radius is equal to 2, that means 2 pi 2 squared divided by 4, which is equal to simply pi. Here 2 to 3 is base is equal to 1 and height is equal to 3. So if I have to cut it down right over here, area of this section would be simply 1.5. Now, then I think we have everything that we need to calculate this one. Here, this portion becomes pi plus 1.5, which will be equal to g of 3 minus 5. 5 was given here. Then g of 3 will be equal to pi plus 6.5. That becomes our answer. Similarly, what we can do is g of -2. G of -2 has to be going from -2 to 0 for g of x dx, and which will be equal to g of 0 minus g of -2. Now, g of from here to here, the area becomes once again from -2 to 0 is equal to pi. So this portion becomes pi. But g of 0 equals 5 minus what we're looking for, g of -2. Then what we end up getting is this. G of -2 will be then equal to 5 minus pi. That becomes our answer. All right, let's look at part B. Part B, here we have find the x-coordinate of each point of inflection. Now, how do you find the point of inflection? Point of inflection from g prime is simply minimum or maximum of g prime. Now, where do we see that? From here to here. We see maximum here, which is when x equals 0. And then minimum over here, relative minimum, which is when x equals 2. And we see a relative maximum over here when g is equal to 3. So those are the only values. Let's look at part C. The function h is defined in this given way. Over here, find the x-coordinate of each critical point. Critical points, basically we have two conditions. When h prime of x is equal to 0, or h prime of x is not defined. So let's look at those two different cases. Here, then we end up getting g prime of x, which we will figure it out from previous ones, and minus, in this case, x has to be equal to 0. Then what does that mean? G prime of x has to be equal to, has to be equal to x. Then we can see from the graph here, When do we have that? If I were to draw the line, just to show you, it would have been around here. There are 2 points for our interest. Right over here, that's the first point, and that is the second point. Now, since slope is equal to 1, then this point must be a 45-degree angle in both ways. So, semicircle where the angle is 45 degrees, and the other point will be this one. So let us try to figure out what those points are. This one is when x equals 3 right away. And this point, if I were to bring the picture out, then what's going to be happening is this. Since the radius is equal to 2, what is the x value? Because this is, if I were to bring this one down over here, right, there will be the right angle. So this, why don't we call that as x? But since x and y are equal to each other, in this case, 45-degree angle, as you can see, that because the slope is equal to 1, then this length must be also equal to this length, equal to x. Then by the Pythagorean theorem, you will realize that this value has to be radical 2. So then here we have, they will be equal to each other when x equals radical 2 or 3. Now, when do you have this one not being defined? That means h prime of x is equal to g prime of x minus x. This second portion is always defined. That's always okay, but g prime, there are a few locations where g prime may not be defined. Let us try to look into that, see if there's any points like that. But along this way, there's no particular point where g prime is not defined. Don't get confused. Here, g prime is equal to 0. Here, g prime is equal to 3. You see? So there's no other point. We're not looking at graph of g. We're looking at graph of g prime. And there's no other place where g prime is not defined. So everything is fine. Only possible case is radical 2 and 3. All right, that's it. I'll see you later.